All right, so we actually haven't done any problem solving. All we've done is vocabulary at this point. But the next step is let's solve some problems. So we're going to turn our attention to doing that. And let's go over these three problems. Notice we don't have any pictures, so we're responsible for drawing the picture. And the picture is important. This is geometry. So let's see what we can do here. Let's take number one. We're going to bring it out here. So take these problems very slowly and draw as you go. First of all, we have an isosceles triangle. That's enough. An isosceles triangle, definition, two sides that are the same, and we know that that also means that the two base angles are the same. So I have a picture of a triangle. The two legs are marked congruent, and the two base angles are marked as congruent. Now I still have to fill in the letters DOG, but at least I have a picture to do that with. So I know the three letters are D, O, and G. I don't know where they go, but if I keep reading, angle G as the vertex. Well, again, vocabulary. The vertex angle connects the two legs. So that one's G. Now, the other ones don't matter. They're congruent. So put O somewhere and put D on the other one. That's it. Now we can look at the information that they gave us and decide what to do. So DG is 22. DG. DO is x plus 2. That's down here. And GO is 3x plus 4. And, well, we're asked to find x and then each side. We're always going to find x. That's not even a question. So now the issue is, how do we find x? And this is where we have to put some thought into it, right? Are we working with the angles? All the angles would add up to 180. But these are not angles. These are segments. So that's not going to do it. So what do we know about these segments? Well, if we look at the picture, because we drew and labeled the picture, we know that two of those segments are congruent. So that's what we're going to do. If they're congruent, then that means they are equal. So we're going to get x that way. Now we were just told find the measure of each side. Well, GD is already 22. GO, we also know, is 22. And if we plug in 6, we find out that OD or DO is 8. So we have our three sides, 22, 22, and 8. So what if the question asks us for perimeter? Okay, we just add them up. 22, 22, and 8 is 52. Right? So it all depends what the question asks for after we get x. But our challenge is going to be, how do we get x? Well, again, it's an isosceles triangle, so we know by definition those two legs are congruent. Mark them in the picture as soon as you draw it. Looking at number 2, and I'm going to bring number 2 out to the side here. Right triangle. Fine, draw it. That's good enough. We have a right triangle. I don't know where CA and T go yet, but at least I have a right triangle to start with. Now I'm going to figure that out. AT is perpendicular to CT. Look at, they both use T, so that's where the lines come together. We know perpendicular lines form right angles. So think about that. Perpendicular lines, and we have a right angle. They meet at T. So there we go. One of the other points is C, and one of the other points is A. Again, we don't know which is which, but geometry doesn't care because that picture can be rotated, reflected. It doesn't matter. Geometry cares about the parts and the relationships. Well, now let's see what information we have. And we were given angle TAC. So TAC, make sure you can find that angle for x minus 1. And ACT, that angle is this one, ACT. Remember, the vertex is the middle letter. That's where the angle lives. 3x plus 14. And of course, we have to find x. Well, again, we always ask ourselves, we are dealing with angles here. What do we know about the angles of a triangle? They always add to 180. So we have 90 plus 3x plus 14 plus 4x minus 1 equals 180. So we have the three angles of a triangle adding up to 180. And then we do some algebra, we do some solving. So what do we have going on here? We have 7x plus 103 equals 180. 7x equals 77, and x equals 11. Now, you could have just done the two angles total 90. You could have done 3x plus 14 plus 4x minus 1 equal 90. Again, the two acute angles of a right triangle are complementary. Or just add them all to 180. It's the exact same work, same results. So we found x. Now we have to find each angle, it says. Well, angle T we already have. That's angle T is 90. They gave us that one. So let's find angle A. Well, we're just going to plug it in. 4 times 11 minus 1 is 43. Angle C. 3 times 11 plus 14 is 47. So we have our three angles, 90, 43, and 47. And they should add up to 180. They do, so we know we're good. And finally, we were told classify the triangle based on its sides. Well, we already know it's a right triangle. That they're not asking us that because they gave us that in the question. But now that we know all the angle measurements and all the angles are different, we can say that all the sides are different, and this is a scalene triangle. All right, one more to do here. Here we're given information on the coordinate plane. So it makes perfect sense to graph the picture. So let's get a graph going. One, two, three, four, five, six, seven, 8. Just need a picture, a reference. So A is at 4, 2. 1, 2, 3, 4, up 2. So that's A. 7, 5. 7, 1, 2, 3, 4, 5, up 5. So it looks like B. And then C is at 0, 6. So there's our picture. And we're asked to classify the triangle. And that's all we know so far. Well, again, think about the different types of triangles. Let's start with sides, right? We could say scalene, all three sides are different. Isosceles, two sides are the same. Equilateral, all three sides are the same. We have to figure out how long each side is, the measurement of each side. So think about what we're going to do here. We need to know how far it is from A to B. and how far it is from A to C, and how far it is from B to C. So we're going to do distance formula, right? Again, everything we do, we're breaking down into a marking period 1 question. Most of this is all chapter 1. It's just hidden inside a triangle now. So we need the distance formula. x2 minus x1 squared, y2 minus y1 squared. And we're going to do it 3 times. We need the distance of AB. We need the distance of AC. And then we need the distance of BC. So again, label your points. If I'm going to use A and B, I'm going to call that x1 and y1 and x2, y2. Make sure that you're plugging in carefully. So x2 minus x1, 7 minus 4 squared. y2 minus y1, that's a 5 minus 2 squared. That gives me a 3 squared plus a 3 squared, or square root 18. And I can certainly grab a calculator and get the square root of 18. And I'm going to get 4.2 or 4.24. Now, it doesn't really matter. We're not being asked what is the length. What we need to do is compare the length to the other ones. Let me just make that a little bit neater, 4.24. So, should I go to the tenths, hundredths, thousandths? I don't know. I could leave it as square root 18. Again, what we're trying to figure out here is, are they the same or different? That's all we really need to know. Are they the same or different? So we can classify the triangle. So it's not really a rule, go to the tenths or the hundredths. It's go to the point where you can tell whether they're the same or different. So now I need to do the other two. So for example, I might do AC. Okay, and this is something that everybody should be doing. Whoops, sorry about that. My screen gets a little jumpy here. So now go back, if we're going to use AC, call x1, y1, and x2, y2. You can only use 2 points at a time, but that's all we need. 2 points for each segment. So again, let's just fill it in. For the x's, it looks like 0 minus 4. And for the y's, 6 minus 2. And again, squared. So it looks like we have negative 4 squared plus 4 squared. And for AC, what do we get here? We get the square root of 32. And the square root of 32, if we grab a calculator, comes out to 5.7. So far, those are different. And we need to do our last one, BC. So again, let's label it x1, y1, x2, y2, and substitute. So for our x's, we have 0 minus 7. For our y's, we have 6 minus 5. That's negative 7 squared. That's a 1 squared. So it looks like the square root 50. And the square root of 50 is 7.1. Now we could see at that radical, we can see that they're all different. Or we went to the decimal. Again, we can see that they are all different. So no matter which approach we use, we are absolutely coming up with scalene. So this is a scalene triangle, right? Whether you stopped at the radical or you went all the way to the decimal, and no matter how many decimal places you carried it, our goal is just, are they the same or different? They are different, so it is scalene. Now, remember, we want to classify based on the angles also, to the best of our ability. Now, if we look at our graph, there's a chance that we have a right triangle. Now, if it's not a right triangle, I have no way of telling if it's acute or obtuse right now. We'll get to that knowledge soon enough, but we should at least be able to say whether we have a right angle. So think about, if we can test for a right angle, how would we test if it's a right angle? Well, remember, right angles come from perpendicular lines. So this is the same as saying test if we have perpendicular lines. And the only place that that's possible in this picture is AC and AB. Is AC perpendicular to AB? That's what we want to find out now. And how would we do that? Slope. So let's find the slope of AC and the slope of AB. So remember slope formula. Y2 minus Y1, X2 minus X1. So this is still marking period 1 question inside the triangle. Think about it that way. This is why, the beginning of geometry is so critical. Now we're just going to find the slope. So the slope of AC. So use the points A and C. Label them x1, y1, x2, y2. But let's figure out the slope of AC. So slope is y2 minus y1. So 6 minus 2 is 4 over x2 minus x1, negative 4. So the slope is negative 1. Now look at the picture. It is going downhill, so negative makes sense. The slope of AB, 5 minus 2 is 3. 7 minus 4 is 3. And we have a slope of 1. Well, it is going uphill, so positive makes sense. But these are opposite reciprocals. Right? They multiply to a negative 1. These lines are perpendicular. So is AC perpendicular to BC? Yes, absolutely. Which means, what kind of triangle do we have? We have a right triangle. And specifically, we have a right scalene triangle. So all that work was first marking period work. Find the distance of 3 different segments. Test if these 2 segments are perpendicular. And when we put all of that together, we found out that those 3 points make a right scalene triangle. The question is a triangle question, but every skill that we used was from chapter 1. The measurement of segments and determining if lines are perpendicular. And that's what we do. We take our questions and we break them down into simpler components. We sub-goal the problem. All right, we'll break from there.